Hello everyone, we are Group PR73 from the Faculty of Engineering and Built Environment. My name is WONG and together with one NAZRIN, Muhammad AMIR and one ZIYI, we will be presenting our case study for engineering ethics and technological advancement. Today, we will discuss one of the most ambitious infrastructure proposals in Malaysia, the Penang Undersea Tunnel. This opening version shows the tunnel as a modern engineering marvel, symbolizing progress and connectivity. However, as engineers, we might ask an important question: does this version reflect reality? So, what is the RM6.3 billion gamble? We refer to this issue as the RM6.3 billion gamble. Proposed in 2011, the project had faced more than 12 years of delays and remains in the pre-construction state as of 2025 and even until now. Most concerning is that RM 305 million was spent on feasibility studies alone without any physical construction. This raises serious ethical concerns regarding financial responsibility. The proposed project included a 7.2 km undersea tunnel connecting from Gurney Drive to Bangar Ajam, along with 3 major payrolls, bringing the total cost around to RM 6.3 billion. While the objective was just to reduce traffic congestion and promote economic growth, the large scale of the project means that any ethical failure has significant public impact. At the center of this case is a controversial land swap mechanism, which has raised concerns over land valuations and transparency. For those who are unfamiliar, it means the state is paying for the tunnel not with money, but by giving away prime public lands to a private developers. The developers build the infrastructure, and in return, they get valuable seafront property to develop for their own profit. This is risky because if the land is undervalued, the public loses a permanent access for a temporary service. The project is currently linked to ongoing investigations by the Malaysian Anti-Corruption Commission (MACC) involving abuse of power and corruption. This leads us to our key question: is the Penang Undersea Tunnel a case of technological advancement or a failure of ethical governance? To further discuss the ethical risks involved, I will now pass the presentations to my team members.
So, for this slide shows our engineering risk assessment using a likelihood versus impact metric. Basically, it helps us understand how serious a risk is and how often it might happen. For the first one is risk with low impact, like minor delays or labor shortage are easier to manage and usually don't affect the project too much. For the second one is high risk, such as cost overrun or site damage need closer attention because they can affect both time and budget. For the last one is critical impact risk, like hydraulic leakage, seismic stress or structural collapse are the most critical and require immediate action. Overall, this metric helps us prioritize risk, focus on what matters most, and make better engineering decisions. So, we move to this slide. This slide highlights the environmental threat associated with the project. While the goal is to improve transportation and connectivity, there are significant environmental impact to consider. For the first one, or the major one, is Major concern is marine biodiversity. Large-scale dredging can increase sedimentation, which may damage coral reef and disrupt local fishes in the surrounding water. For another issue is coastal erosion. Change in water current can accelerate erosion along coastal areas like Gurney Drive and Butterworth. For the conclusion for this slide is this environmental threat shows that development need to be carefully planned to balance infrastructure growth with long-term environmental sustainability. For this slide, I want to show the photographic evidence for site visit and interview. On 12 January 2026, my groupmate and I went to SMART headquarters to do some interview and site visit for our report. So we asked some question about tunnel, such as how the maintenance for tunnel works and what's the difference between smart tunnel and undersea tunnel.
First, safety. Compared with Kia Smart Tunnel, Penang's undersea tunnel faces irreversible risks from deep sea pressure. It has few evacuation points and unclear rescue plans, and corruption issue reduce its transparency, breaking the duty to keep the public safe. Next, cost. The total project cost is 6.3 billion ringgit, with 3.5 million ringgit spent to the feasibility study, nearly 5% of the total, which is higher than the 2 to 3% industry standard. This cost is paid via controversial land swaps, making it a wrong use of public funds. Finally, transport. The first bridge is 95% utilized, but the second is only at 60% capacity, since 85% of people travel by car. Building the tunnel will attract more cars, causing more traffic and pollution, which is unfair to the future.
If we look at the project from an engineering ethics and perspective, first is utilitarianism, which is basically about doing the greatest good for the greatest number. Even though the tunnel could reduce travel time, we need to ask whether that the benefit is worth the massive cost and long-term environmental damage. Next is deontology, or duty of care. As engineers, public safety should always come first. However, the lack of clear safety and emergency planning raises serious concern about whether this duty is being fulfilled. Lastly, virtue ethics focus on integrity and good character. The land swap mechanism and ongoing corruption cases damage public trust and clearly go against ethical engineering values. So, instead of rushing into construction, there are better steps moving forward. First, the project should be reviewed by independent international experts to make sure safety and design decisions are unbiased. Second, transparency matters. The public deserve full access to environmental and visibility reports, so decisions are made openly. And lastly, alternatives like LRT expansion or water transport should be prioritized since they are lower risk and more sustainable. To conclude, the Penang Undersea Tunnel may be an impressive engineering idea, but our analysis show that technical capability alone is not enough. The high cost, environmental risk, and governance issue raise serious ethical concerns that cannot be ignored. From this case, we learn that engineers must always balance innovation with responsible safety, transparency, and public interest should come before political or economical pressure.